Welcome to this short demo where we are going to show you an example of the implementation of Layer 2 circuit provisioning orchestration for the GP4L devices using a digital twin of the environment created in Container Lab. For these purposes we also used Airflow as the orchestration engine, MAAT as the single source of truth, and LSO and Ansible for network devices configuration. We will first inspect the GP4L devices in Container Lab that are going to be used as the targets of this Layer 2 circuit provisioning demo. This Container Lab topology is a digital twin of the GP4L core network. The four GP4L switches are AMS0001, FRA0001, BUD0001, and POZ0001. Each of them has a management address in the 172.16.26.0/24 subnet. In addition, each switch has two data plane interfaces, which are Ethernet 1 and Ethernet 2. For example, Ethernet 1 on AMS0001 is directly connected to Ethernet 1 on FRA0001 through a link. MAAT is used as the source of truth for the GP4L topology. Each switch is stored in MAAT as a resource under the device switch category. It has resource characteristics such as hostname, ID, and management address. In addition, each switch has a resource relationship with each of its two data plane interfaces. The two data plane interfaces are also modeled as resources in MAAT. We can trigger the Layer 2 circuit provisioning service using the MAAT graphical user interface. We fill the parameters of the service, including the endpoints of the circuit, the VLAN ID of each side, the MTU, and the bandwidth. Submitting this form will trigger the corresponding direct acyclic graph in Airflow. In Airflow, the Create Layer 2 circuit workflow will first validate the input parameters. It will then configure the targeted GP4L switches via the lightweight service orchestrator, Ansible, and Ginger 2. As its final task, if there are no errors, it will update the resources and create the services in MAAT. After the workflow is completed, we can check that the Layer 2 circuit service and its two associated service access points have been created in MAAT. The service access points are modeled in MAAT as services and have a resource relationship to the interface resource of the corresponding side of the circuit. Additionally, the involved interfaces will also have a new service relationship to the corresponding service access points. Now, we can verify the configuration in the GP4L devices inside the Container Lab digital twin to see the new VLAN interfaces with the parameters we specified. We will see that new interfaces Ethernet 1.100 have been created. Next, we will apply Layer 3 configuration on top of the Layer 2 service that we just created to test it. We can now test connectivity over the created Layer 2 circuit by executing a ping. To remove a service, we can also use the graphical user interface to trigger airflow. We are going to remove the Layer 2 circuit that we just created, and verify the successful removal of the service in MARAT and in the GP4L devices. Now that the workflow is completed, we can check if the service and its relationships are removed in MARAT. We can also validate the service is removed from the GP4L device's configuration as well. Thank you for watching this short demo on Layer 2 circuit provisioning in GP4L. If you have any questions or would like to get more information, please visit the GP4L website or drop us an email.